This is Mathematics Paper 1, the June 2016 Common Test for the province of KZN, grade 11. It's a 100-mark paper, 2 hours, and we're going to begin with question 1. Question 1 is solved. Okay, 1.1.1. We're given 2x minus 3 over x is equal to 1. The first thing you need to know when you see something like this is that anytime you see x in the denominator, you're typically going to want to try to get x into the numerator by multiplying both sides by x. That's going to give you a quadratic equation. So let's do that. Let's go 2x squared minus 3 is equal to x. 2x squared minus x minus 3 is equal to 0. Great. So one thing you need to be aware of is that because you multiplied both sides by x, you've introduced a variable into the equation. When you multiply both sides by a constant, there's never really any issue. You haven't changed the equation at all. But when you multiply both sides by a variable like x, you have to be very careful. And I'll do a little example on the side to show why you have to be careful. Let's say you have a simple example like x plus 7 is equal to 9. Let's say you multiply both sides by x. So you get x squared plus 7x is equal to 9x, which gives you x squared. 7x minus 9x gives me minus 2x is equal to 0. Factorize x. Your two solutions are x is equal to 0 and x is equal to 2. Now, one thing you have to note here is that if we substitute x is equal to 0 in the original equation over here, it doesn't solve the equation. You get 7 is equal to 9, which is not true. So this solution can't work, and this is the correct solution. So what happens when you multiply both sides by a variable like x, unlike a constant, is you introduce the possibility of another solution, and that solution may well be wrong. So when you get an equation like this, where you're going to take x to the numerator and you get a quadratic, it's really important to check your final result, which we'll do. The other thing that's important to note is because x started in the denominator, one solution that won't be allowed to work is x is equal to 0. In fact, you can even write this right at the beginning. You already know that x is not 0. So when you get questions like this and you solve them, you really have to check your final solution. Okay, so we're going to factorize this. We're going to say we're looking for two numbers whose product is 6 and whose difference is 1. The two numbers are 3 and 2. We draw the cross like that. And we want to make a minus 3x, and we want to make a plus 2x. Why? Because that gives us the middle term of minus x. So the plus 2x we can make from this 2x by multiplying it by 1. And the minus 3x, we make it from this x by multiplying by 3. So the way you check this is, does this part here, the product of this gives me 2x squared. The product of this gives me minus 3. If I take 2x minus 3x, I get minus x. So then the factorization is 2x minus 3 plus 1 is equal to 0. Now, this method, if you're not familiar with it, you can Google, it's called the AC method. It's very simple, but very useful. And it's one of the fastest ways to factorize, especially with complex polynomials. Right. So from the solution, we get x is equal to 3 over 2. That comes from the first bracket being equal to 0, or x is equal to minus 1. Now, thankfully, we don't have x is equal to 0 as a solution here, so at least we know that's not a problem, but we still need to check. If you substitute 3 over 2 into this equation, the first term will be 2 times 3 over 2, which is 3. The second term will be 3, the whole divided by 3 over 2, which is the same as 3 times 2 over 3, which gives you 2. So then you have 3 minus 2 being 1. So this solution is valid. As for x is equal to minus 1, we'll have minus 2 here, and we'll have plus 3. Minus 2 plus 3 gives you plus 1. So this solution is also valid. And we're kind of lucky that it worked out that way. But whenever you're multiplying both sides by x, especially if you're trying to remove it from the denominator, you absolutely have to check your solutions. There's just no two ways about it, because sometimes one of them just won't work. All right, next question. 1.1.2. Solve the following equation. Again, it's the same question, but it's useful to remember what you're actually trying to do. So we're given this quadratic equation, 3x squared minus 6x plus 1 is equal to 0. And we have to solve it, correct it 2 decimal places for 4 marks. So usually when you have to correct it to a number of decimal places, you know that they want you to use a quadratic equation. And we can do that. If you try using the factorization, you'll see that that method won't work. So there's nothing wrong when you're writing an exam with being really explicit about what you're doing. You can always write a lot of extra information just to guide yourself as you go along. So you can write, this is a quadratic equation of the form ax squared plus bx plus c is equal to 0. And you should always check that this is a 0 here. Sometimes it'll be like a 7, and you have to take it to the other side, where a is equal to 3, b is equal to minus 6, c is equal to 1. And note this minus. Anytime one of these coefficients is minus, you have to be really careful using the quadratic equation, because it's easy to forget the negatives. So therefore, by the quadratic equation, x is equal to minus of b. b is minus 6. Minus of minus 6 gives me 6. Plus or minus root of b squared. b is minus 6. The square of that is positive 36. b squared minus 4 times a. a is 3 times c. c is 1. The whole over 2a. That's the quadratic equation. So solving this equation, we get 6 plus or minus root of 4 times 3 is 12, and it's a negative. So 36 minus 12 is 24. The whole divided by 6. Right? Which can be written as 1 plus or minus root of 24 over 6. So the first solution is x is equal to, and then we need to use a calculator. Just use the one on my computer. So it's 1, the first solution is 1 minus the square root of 24 divided by 6. So I just need to make sure that this calculator has done the BOD math right. So what I'll actually do is I'll take 24 divided by 6, square root of 24. Square root of 24. Okay, let me do that again. This calculator doesn't even have brackets. Okay. So we're going to use our calculator, and we take 1 minus, take a bracket, square root of 24. So I need to put it under a root sign. Terrible calculator. Let me just use the one on my phone. So we use a calculator and we get x is equal to 1 minus root of 24, the whole over 6. And the solution to that, I'll just type it in on my calculator. And that gives me 0.1, and remember 2 decimal places, so it's 183, so that's 0.18. And the other solution gives me 1.82, rounded to 2 decimal places. Both of these are solutions. Right. Simple enough. 1.1.3. Cool. 5x minus 2 times x squared minus 6 is less than or equal to 0. This is not an equation, it's actually an inequality. But the solution is pretty much the same, it's very similar. The first thing is we want to get this into a standard quadratic form. So we're just going to rearrange that. So that's going to be 5x minus 2x squared plus 12, 2 times 6 is 12, is less than or equal to 0. Put the highest power in front. And then we take 2x squared, we're going to take negatives all through, just so that this is a positive number. And remember, with an inequality, when you take a negative, the sign flips. Right. So, what does this actually mean? Well, what you can imagine is, you can say, given a parabola, f of x is equal to, and you take the left-hand side, 2x squared minus 5x minus 12. What you can do is you can draw the x-axis, and then you draw the parabola. Because it's positive on the x squared, it's going to look like that. All right. For this parabola, we're going to have 2 roots. Let's call this root x1. Let's call this root x2. Let's name this parabola f. F is positive on either side of its roots. Full stop. The roots of f are so how do we get the roots of a parabola? How do we get the roots of a quadratic equation? We factorize. So first thing we need is the quadratic equation itself. So we're going to say 2x squared minus 5x minus 12 is greater than or equal to 0. Oh, sorry. For getting the roots, we want the points where it is equal to 0. Is equal to 0. Okay. And if we now solve this quadratic equation, what do we get? We get the roots. So we're looking for 2 numbers whose product is 24. Whose difference, because this is a negative, is 5. In fact, minus 5. What we have is 2x and x, and we want to make 2 numbers whose product is 24 and difference is 5. The numbers are 8 and 3, because 8 and 3 give you a product of 24 and a difference of 5. So the middle term, minus 5x, this middle term will come from minus 8x plus 3x. So to make the minus 8x, we can use this 2x. We can go minus 4. And to make the plus 3x, we can use this x here. We can go plus 3. 2x times x indeed gives me 2x squared. 3 times minus 4 gives me minus 12. And 8x from this branch minus 8x from this branch plus 3x from this branch gives me minus 5x. So the factorization is 2x plus 3, x minus 4 is equal to 0, x is equal to 3 over 2, or x is equal to 4. So if we just scroll up, what we're saying is that this x1 is 3 over 2, 1.5. And this x2 is 4. So this is 3 over 2, and this is 4. To the left of 3 over 2, the parabola is positive. This term, which is the left-hand side of our inequality, 2x squared minus 5x minus 12, is positive when x is less than 3 over 2, or when x is greater than 4. So we just write that as our solution. Therefore, the solution to the inequality, given inequality, is x is less than or equal to 3 over 2. In other words, it's to the left of the first root, or it is the first root, because remember it was less than or equal to 0 originally. And some people say or, x is greater than or equal to 4. The sign change that we did makes no difference, because if we had drawn the original parabola, this one here, it would be less than or equal to 0, which means between the two roots. Then the parabola would be flipped. The parabola would be flipped, which means that the parabola would be negative still when x is less than 3 over 2 or when x is greater than 4. So this sign change didn't make a difference. Okay, next question, 1.1.4. 2 plus root of x plus 2 is equal to 6 minus x. And again, we're trying to solve. So whenever you're trying to solve an equation, you're trying to isolate x. The problem here is that x has two operations on it. In addition to what's happening on the right-hand side, x is added to 2, and more importantly, it's under a square root. And we want to get rid of that square root. To get rid of any operation done to x, you simply do the inverse. So if you have x plus 7, you take x minus 7. If you have 3x, you take 1 over 3 times 3x. That gets rid of the 3. So since this is under a root sign, what we want to do is we want to square both sides. If we were to square both sides as they are, anytime you square a binomial, like a plus b, you end up with a squared and with b squared, and of course we want the b squared here. We want to get rid of the square root. But you also end up with a middle term. The middle term in this case would be 2 times 2, 4, square root x plus 2. So we would still have this square root. So the first thing we need to do is make this not a binomial by getting rid of this 2. Take it to the other side. It's minus 2. Minus 2 plus 6x gives me 4 minus x. And then we can square both sides. And this root sign simply disappears. X plus 2 is equal to, you can just square this as normal. It gives you 16 minus 2 times 4 times 1, which gives me 8x plus x squared. If we write the right-hand side first and we write it in order of descending power, we get x squared minus 8x plus 16 is equal to x plus 2, which we can simplify as x squared. Take the x here, minus 9x plus 14 is equal to 0. And then looking for two numbers whose product is 14 and whose sum is 9. Two numbers whose product is 14 and whose sum is 9. The two numbers we know will be 7x and 2x, because 7 times 2 gives you 14 and 7 plus 2 gives you 9. But because this is a negative, to get the middle term we need minus 7x and minus 2x. We make our little cross. This time it's simple, it's just x. So we have x here and x here. We make minus 7, make minus 2. And we can check x times x, x squared. Minus 2 times minus 7, plus 14. Minus 7x, minus 2x, minus 9x. So x minus 2, x minus 7 is equal to 0, which gives me x is equal to 2 or x is equal to 7. Now, if you remember from question 1.1.1, I said anytime you're multiplying both sides by a variable, you need to make sure you check the solution, because one of the solutions you've introduced might be invalid. In this case, we squared both sides, and it's a similar problem there. You need to make sure that because we've introduced this quadratic, both of our solutions work in the original equation. So we'll check that. In the first equation, substitute x is equal to 2. Then we get 2 plus root of 4, which is 2. So 2 plus 2 is 4 on the left-hand side. On the right-hand side, we get 6 minus 2, which is also 4. So the first solution, x is equal to 2, is valid. The second solution, x is equal to 7. Let's try that. 2 plus root of 7 plus 2 is 9, so root of 9 is 3. 2 plus 3 gives me 5, right? And then on the right-hand side, if we substitute x is equal to 7, we get 6 minus 7, which is minus 1, not 5. So the second solution is not valid. I can write it out explicitly, just on the side here. You have 2 plus, if x is equal, so you write if x is equal to 7, then left-hand side gives you 2 plus root of 9, which is 2 plus 3, which is 5. Right-hand side gives you 6 minus 7, which is minus 1. And then the left-hand side is not equal to the right-hand side. So that means x is equal to 7 is not a valid solution. Not a valid solution. And the reason is because when we squared, we introduced a new variable x, which made this quadratic. And quadratic solutions have 2 solutions, whereas the original equation would only have 1. So one of the solutions we introduced is invalid. Anytime you're multiplying both sides by x, or you're squaring the entire equation, you need to check both the solutions. And it might be useful to actually just write this check here, just underneath your solution. That could count for marks. Great. So 1.1.5. 3 raised to 1 minus 2x minus 1 is equal to 0. Again, solve for x. So the way we solve these problems where the x is in the exponent is we solve it by comparison. We need to make sure that we have some base, in this case 3, is raised to something with x is equal to 3 raised to something without x. So if we can write that, we got 3 raised to 1 minus 2x is equal to 1, which means 3 raised to 1 minus 2x is equal to 3 raised to 0. And using logic, if 3 raised to something is the same as 3 raised to 0, that something must be 0. So we write therefore, because we're making a logical deduction. 1 minus 2x must be equal to 0, which means x is equal to 1 over 2. You get that by taking 2x to the other side, divide both sides by 2. So x is equal to 1 over 2. That's the solution. Next question, 1.2. Solve for p if the roots of 4x squared is equal to p minus 5x are real. So what are we given? We're given 4x squared is equal to p minus 5x. This is a quadratic equation, and we can write it in the standard form. 4x squared plus 5x, taking 5 to this side and taking p to this side, minus p is equal to 0. And remember when I said you have to write things out explicitly and it helps you along? You can do that here. You can say a quadratic equation of the form ax squared plus bx plus c is equal to 0, where a is equal to 4, b just means the coefficient on the x term. In this case, it's 5. And c means the constant, which in this case is minus p. Minus p, of course, is unknown, but it's not a variable in the sense that x is a variable. So in this case, c is equal to minus p. And what they want to know is solve for p if the roots of 4x squared is equal to p minus 5x are real. Well, the roots of this equation are, and how do we get the roots of an equation? Well, we have a, b, and c, so we use the quadratic formula. X is equal to minus b, in this case b is 5, plus or minus root of b squared, 25, minus 4, a is 4, from there, c is minus p, the whole under the square root, all divided by 2 times a, using the quadratic equation. So they're saying the roots of this equation are real. So the roots of this equation are the solution to this equation, and the roots are real. When are the roots of an equation real? When the discriminant, also known as delta, the part under the square root, is greater than or equal to 0. So the roots are real when delta equals the discriminant, which is equal to 25 plus 16p is equal to, is greater than or equal to 0. So we solve the inequality. What we have is 25 plus 16p is greater than or equal to 0. So we can take 25 to the other side. 16p is greater than or equal to minus 25. So p is greater than or equal to minus 25 over 16. So all we've said is that every time p is bigger than minus 25 over 16, the discriminant of the equation, the part under the root, will be 0 or will be positive, which means that all the roots will be real. And so that's the solution to this original problem. Right. Last question for question 1. 1.3. Solve for x and y simultaneously if x minus 3 is equal to 2y. That's our first equation. And also, x squared minus y squared is equal to 45. The second equation. Right. We usually would use the equation where everything is in a first degree and put that into the second degree equation by substitution, rather than try and get a square root here and put it there. So we try and put equation 1 into equation 2. But first, we want to rewrite equation 1 so that we're solving for one variable. So let's say x is equal to 2y plus 3. That's our equation 1. And x squared minus y squared is still equal to 45. That's our equation 2. Right. Now, what we're going to do is we're going to put equation 1 into equation 2. So we're going to say 1 into 2 gives us equation 3. Substitute x is equal to 2y plus 3 into this equation. Then what do we get? We get 2y plus 3 the whole squared minus y squared is equal to 45. Now this is a simple quadratic equation in y. We've got 4y squared here plus 2 times 2 is 4 times 3 is 12 plus 9 minus y squared minus 45 is equal to 0, because we want to have everything equal to 0 in the standard form of a quadratic equation. Handling the y squareds first. 4y squared here minus y squared gives me 3y squared. 12y, there's no other y term, so it stays. 9 minus 45 gives me minus 36, being equal to 0. There's a common factor of 3, which we can remove just to make the maths easier with smaller numbers. And this is now the simplest quadratic we have. We need two numbers whose product is 12, whose difference is 4. Right? What are the two numbers? 6 and 2. So to get the middle term, we need plus 6 and minus 2. Draw a little cross. We have y squared from here. Now we need to make a plus 6y. So we can make it with this one. We can go plus 6. Because the product of these will give me plus 6y. And if I put a minus 2 here, the product of these gives me minus 2y. So y times y gives me y squared. Minus 2 times plus 6 gives me minus 12. Y times 6 gives me plus 6y. Y times minus 2 gives me minus 2y. 6y minus 2y gives me 4y, positive. So that means y minus 2 times y plus 6 is equal to 0. So we can say y1 is equal to 2 and y2 is equal to minus 6. Right. So let's just get the solution visible there. Back into equation 1. So equation 1 was x is equal to 2y plus 3. And you say, if y1 is equal to 2, then x1 is equal to 2 times 2 plus 3. 4 plus 3 is 7. And if y2, the second solution, is equal to minus 6, then x2 is equal to 2 times minus 6 plus 3. This gives me minus 12 plus 3 is minus 9. So our two solutions, the two solutions are 7, 2, and minus 9, minus 6. And what does this actually mean visually? Well, if you imagine the visual version of this, the first equation corresponds to a straight line. The second equation, x squared minus y squared is equal to 45, corresponds to a hyperbola. It looks like that. And what we're saying is just this is where the two curves, the line and the curve, intersect each other, which is a little bit advanced because in high school we don't deal with hyperbolas that look like this, but there's a visual solution anyway. Right, so that's question 1 done. That's 29 marks out of 100. You just need another 21 marks to get a 50%. This paper is not actually too bad so long as you look out for all the tricks. Moving forward to question 2.